Hello and welcome back. In this video we're going to briefly talk about sequences, tuples, and parallel assignment. So lists and range objects that we've already seen are just examples of a more basic Python type called the sequence. Keys to a sequence is that it can be indexed, as we've seen already, using the square brackets to grab hold of a particular element in a sequence, and it can also be iterated over using a for loop, as we've seen several examples of this week. Strings are also examples of sequences. So if we have a string like name is Fred, the indexing capabilities we've seen for lists are also available for our strings. So we can go in and say name indexed by 0, we'd expect to be F, and it is, and name indexed by, let's say, 1 to 3, is going to give us the subrange, which is RE. And we can also iterate over our sequence that is a string. For car in name, we can print out what that character is. Okay, and everything's as we'd expect. So strings are sequences, lists are sequences, range objects are sequences, and next we're also going to introduce the tuple as another type of basic sequence. Lists, remember, are lists are mutable, which means that we can change them. Strings are immutable, which means that once an object's been created of a string type, you cannot change that object itself. You can certainly create new objects stored at different locations on the computer's memory, but you cannot go in and change one particular string after it's been created. And that's the same for tuples. Once they've been created, they're immutable, they cannot be changed. Same also for range objects. Once created, they can't be changed. And that means we can't assign into slices of any particular string object. We can't reach and grab a subset of elements from a string and say replace that subsequence with another subsequence. So tuples are a bit like a restricted form of list, and they use parentheses instead of brackets for their definition. So we can say point, assigned to a variable point, a tuple that contains just an x and y value, let's say, and we can check that Python has correctly inferred the type of that. It knows that that's a tuple. We could also create person is a tuple, so we're using again the brackets. Sorry, we're using parentheses here to say Fred, a first name, a second name, and an age. We'll just leave it at that. So this is a tuple containing 3 elements in its sequence. And we can say what is person, and it's showing me that it's using the parentheses here to say that, yep, this is a tuple that contains the following 3 elements. An empty tuple is created by the open and close parenthesis. Again, we can say what's the type of empty just to confirm that, and it's telling me it's a class tuple. And if you want a singleton, so a tuple that contains only a single element, well, there's a trick here in that you have to include the comma after the single element. So the example on the slide over there has a single element that's a string. I'm creating a single element tuple that is using an int, but the comma must be present. It's a little bit weird syntax, but this is essential for Python to tell that you're intending a tuple instead of a very simple expression. So we can look again at what's the type of single, and here it's a class tuple. So the big difference between tuples and lists are that tuples are immutable, meaning once we've created it, we can't go off and modify the contents of that tuple in any way. Also, lists have many methods available, but tuples have only 2. There's just count and index, which may make them seem really restricted, but they're there for specific purposes, including their use as keys for dictionaries, which we'll get to later. So most of the time, I suspect, you'll be wanting to use lists. But lists are used when all elements have the same type, so a list of marks, or a list of names, or a list of addresses. Every element in the list has exactly the same type. So, and in those cases, it makes sense to think of things as lists. So you use tuples if any of the following are true. You're dealing with inhomogeneous data, meaning you have an object, a very simple object likely, that has slightly different types of data, like the first element is going to be a name, the second element is an address, and the third element is an age. Okay? It doesn't make sense to think of an element like that, or an object like that, as a list. It makes sense to think of it as a tuple, a collection of different types of data. It can also make sense to use tuples if you think of the combined elements as being part of a single object. So you might be modeling a person's detail for a contact list, so their name, address, mobile number, and so on. But typically, you'd prefer to model that using classes and object-oriented programming, which we'll get to towards the end of the course. One of the main uses for tuples is if you actually need their immutability. And this is the case if you're using tuples as keys for a dictionary. Again, that's a data structure you'll learn a lot more about later on in the course. When we need to convert between sequences like tuples or strings or a range and a list, we can do so easily using a built-in function called list. This is actually a special type of function called a constructor, but as we can see in the examples above, we can convert any type of sequence into a list as follows. So list of the string Angus will give us a list that is the individual elements of the sequence in the string Angus, so A, N, G, U, S. If we pass into list a tuple that is, let's say, 5, 3, and 1, well, the argument here is a tuple, 5, 3, and 1, but what we'll get as a result is a list. So it's just converting between these types. So list of the range, let's see, 4 to 10 gives us a list now that is all of those values in sequence. Okay, so it's easy to convert between different types of sequencing objects and lists. Oh, one more thing to point out is that Python's very flexible in its use of variable names. So it allows lots of things that are actually crazy to go ahead. So you've just seen me use the list function to do a series of data conversions. But if I use the keyword, the name list to, say, refer to an integer value here, Python's perfectly happy for me to do so. So I've now got list referring to an int value. And if I now try to use list to convert a sequence like Angus, it's no longer going to work because the thing referred to from list is no longer the function that it originally was. It's now just an int object. So take care with assignments like that. If there's a keyword in Python, make sure you're not making an assignment to it. So str, len, list, any of these names can be overwritten. Take care not to do so. So I'm going to restart my shell to make sure things are fresh and ready to go again. Python has a wonderful ability to do something called parallel assignment, which greatly assists working with sequence types and tuples in particular. So we can unpack the elements in a sequence and assign them to individual elements really easily. So let's say, using a tuple example, I have a person, tuple modeling a person, so I have Fred logs is 27 and has a particular zip code. I'm leaving out the address here. So there we go. We can look at a person. It's modeled as a tuple appropriately. I can do an assignment to unpack each of those components in a single assignment segment. So I can say first, last, age, zip equals. So this is a parallel assignment equals person. Now, person contains 4 elements, 1, 2, 3, 4, and I've named 4 particular elements to do an assignment into, and what's happened in this assignment is all 4 elements have been unpacked in the same statement, and zip. So this is a really very handy, quick and easy way to unpack a series of values that are passed, say, to a function using a tuple. It does work with any other sort of sequence as well. So if I have a string that is, let's say, yeah, let's just do a short example. So A, B, and C, these are bad variable names, but I'm doing a very quick example here. A, B, C equals 1, 2, 3. On the left hand side of the assignment statement, I have 3 values, and on the right, my sequence does contain 3 values. So having done that, A is the string 1, B is the string 2, and C is the string 3. If I tried to do the same thing, like A, B, C, so there's my parallel assignment attempt equals 1, 2, 3, 4. My sequence on the right contains 4 elements. I've got 3 variables to unpack it into, and this is going to give me a value error because I've got too many values to unpack. So as the rule here says, the right-hand side can be any sequence of the same length as the left-hand side. This is particularly useful, though, with tuples. Finally, for today, the enumerate function takes a sequence as a parameter and returns a new sequence, an enumerate object, with index value pairs. So if we've got a list of, say, 3 names, let's create our names as a list that contains Joe, Alice, and Anne, as the example shows there. So names refers to a list, right? I can now create an enumeration of those objects, and I'm going to turn it into a list just to allow you to see this object. So my enumerate object applied, my enumerate function applied to names is going to give me a list that contains a combination, a series of tuples, where the tuples contain a combination of the index and the value. So it's telling me here at index 0 there's Joe, at index 1 there's Alex, and at index 2 there's Anne. We can use structures like this, the enumerate function, to simplify some of our earlier functions, like our updated list pattern scaling up function. So scale up receives has 2 parameters, nums and scale factor, and we can write it as for I, num, so this is using parallel assignment in enumerate nums. Okay, so the enumerate object is going to return this object that has a series of elements of this form. Okay, except it'll be 0 in the first number, 1 in the second number, 3 in the third number. I can then simplify my function. I can change what's indexed from each of those elements to whatever the value is multiplied by the scale factor. So that was very brief. It's important you give this a go in your own time. But that's the way you're going to learn it. So try it out. Thanks.